In this lesson, we'll learn about depth of field. Depth of field basically is the range of acceptable sharpness within a photo that will appear in focus, or in simpler terms, the parts of the image that are in focus. Hey folks, welcome to MoGraph Plus. This video is a free sample from our course, The Ultimate Introduction to V-Ray for Blender. It's a massive 13-hour course where we dive deep into every aspect of V-Ray for Blender, everything you need to know step by step. If you'd like to master V-Ray inside Blender, make sure to check out the full course. You'll find the link right down in the description. And of course, don't forget to subscribe and hit the bell icon so you'll get notified whenever we post new tutorials and lessons. If the areas of focus are very small in the image, like this first render that we have a shallow or a narrow depth of field. Hey folks, welcome to MoGraph Plus. This video is a free sample from our course, The Ultimate Introduction to V-Ray for Blender. It's a massive 13-hour course where we dive deep into every aspect of V-Ray for Blender, everything you need to know step by step. If you'd like to master V-Ray inside Blender, make sure to check out the full course. You'll find the link right down in the description. And of course, don't forget to subscribe and hit the bell icon so you'll get notified whenever we post new tutorials and lessons. Here you notice these cubes are in focus. And as we get closer from these cubes to the camera or from them towards away, the image gets more and more out of focus. This gradual change from focus to out of focus areas happens very fast. Here we say we have a shallow or narrow depth of field. On the other hand, like our next render, if the areas of focus are very large in the image, we have a wide or a deep depth of field. In this image, you can clearly see a larger area is in focus compared to our previous render. Now, to give you a sense of the scene scale here, these cubes are about 10 centimeters each, and this first V-Ray camera is our main cam here. Now let's see where we can enable depth of field in our V-Ray physical camera and what factors control the depth of field in our renders. If I select the first camera and get out of it, you can see the focal plane of the camera or its focus distance is on these few stacked objects, and it is set to around 3.9 meters. We can change that later on if we want the camera to focus on something else. Let's get back to the camera and open up VFB and start interactive rendering and select the camera. We already have depth of field enabled. In order to enable depth of field, simply go to the DOF and motion blur tab of the physical camera and enable depth of field. Right now the exposure mode is set to exposure value, so changing the F number wouldn't affect the exposure. The deciding factor on how narrow or wide the depth of field is the aperture size, which is being controlled by the F number. In the previous lesson, we learned that smaller F numbers means larger aperture size and larger F numbers mean smaller aperture size. Now we need to add another concept here. The smaller the F number, the larger the aperture size and also the narrower the depth of field. And on the other hand, the larger the F number, the smaller the aperture size and the wider the depth of field. Just to simplify this again, the smaller and lower your F number, the narrower or shallower the depth of field, and the larger and higher your F number, the wider or deeper the depth of field. Now let's try a few F numbers. At something like 0.75, we get a very, very shallow depth of field. Let's try 2. Still very shallow but wider. Try 2.8. 4, 8, and finally 16. When set to 16, you can see we have quite a wide depth of field and most of the scene is in focus and looks sharp. For now, let's set the F number to 0.75. Now, if I want to focus on the objects in the back, for example, I can simply change my target or focus distance. Let's try something like 4.8 meters. Or if I want to focus on these closer cubes, I can try something like 3.5 meters. Or I can use this focus object and pick an object like this upper cross so the camera can measure the focus distance based on that. Another very important factor in depth of field is the scene scale. Basically, the smaller your scene and your object, the shallower the depth of field and vice versa. Another important factor in how narrow or wide the depth of field is going to be the focal length. And the rule here is that the longer the focal length, the shallower the depth of field. It's not as important and as deciding as the f number, but it does contribute a bit. So this is the render we get with the focal length set to 130 millimeters. And another one with the focal length set to 80 millimeters. I'm going to switch between the two. We can clearly see that the longer focal length of 130 millimeters produces shallower depth of field compared to when an 80 millimeter lens was used. For now, let's set it to 130 millimeters. Now let's take a look at the bokeh effect section of the Very Physical camera under the DOF settings. For this, I'm going to look through my second camera and also use the second dome light that we have in the scene. And start IPR if it's not already running. Bokeh, if technically defined, is the quality of out of focus or blurry parts of the image, or simply the pattern exhibited in areas of the image that are out of focus. In the bokeh effect section, first we can control the aperture shape. When parts of photo are very much out of focus, the blurred highlights in the photo tend to take on the shape of the lens aperture. Because this aperture shape checkbox is disabled, so the out of focus highlights will have a circular shape. But if I enable aperture shape and set the blades number to like 3, now we have a triangular aperture, which results in a triangular out of focus highlights. Let's try 4. And we get rectangular out of focus highlights. Let's try 5 and 6 as well to get pentagonal and hexagonal highlights. Instead of using only circular or bladed types, you can enable this bitmap aperture and define your own bokeh pattern. If you wanted to get like a circular aperture by using the bitmap aperture mode, we would have used a white circle that fills a black background. So you can create your own shape on a black background and use it here as the bokeh texture. For now, let's disable bitmap aperture and use a triangular aperture shape. And we have this rotation value, which allows us to rotate the aperture and therefore rotate the out of focus highlights. Let's try 45 degrees maybe. And as we can see, we have rotated the out of focus highlights. For now, let's disable aperture shape so we can get circular bokeh. Next, we have center bias. This parameter biases the transparency of the aperture towards the center with negative values or the edge with positive values. Positive values increase the amount of blurring in out of focus areas, while negative values decrease the blur. 0 is the default value. Let's try 1, 2, 3, and 5. Positive values also produce this highly sought after ring effect. For now, let's set it to 0. At this point, I'll get back to my camera and select it and also switch back to the first dome light. Next, we have anisotropy or anisotropic lens parameter. Here you can simulate an anamorphic lens by stretching the aperture vertically with negative values or horizontally with positive values, and therefore stretch your out of focus highlights. Let's try negative 0.65. The effect is a bit exaggerated, but you can use smaller values to get more realistic anamorphic effect. As you can see, the bokeh is vertically stretched. At 0, we get a normal depth of field without stretching. Let's try 0.65, which stretches the bokeh in a horizontal direction. Let's set the anisotropy to 0 for now. Optical vignetting vignettes the frame by simulating the cat's eye effect that some wide-angle lenses can generate. That bending of the pixels that happens at the corners. Let's try 1, 2, 2.5, 3. For now, let's set it to 2. Let me stop the IPR and show you two renders. In the first one, optical vignetting is set to 0, and in the next one, it is set to 2. You see this beautiful cat's eye effect on the corners compared to our simple render. Very cool. For the final render, let me stop IPR, change the resolution to 1500 by 2000 pixels, and make sure the resolution scale is set to 100%. Change the denoiser to Intel Open Image Denoise. We can lower the noise limit a bit as we are rendering a very shallow depth of field, but I think the denoiser will take care of the noise. Now if I render the scene, this will be the final result. So that's about depth of field in V-Ray for Blender. See you in the next one.